What to do, fellas, and welcome back to the channel. Today we're going to be going into project number 5 in the How to Get Started with Arduino series. In this project we're going to be building kind of like an speaker kind of instrument. It is an instrument more, it's called a theremin, which works by, it plays kind of a sound based on the musician's hand movement. That is something you see in an opera maybe. Instead of it being a movement in this video, we're going to be making it so it works by taking in light and determining what kind of sound it has to play based on the light. Very exciting. So without further ado, let's just go into the project and we'll go more in depth as the project moves on. For this project, we are going to need, of course, the Arduino board, the breadboard. We need a 10 kilo ohm resistor. We need a piezo. This is a new device, which is the device that will make the noise kind of come out, kind of like the speaker. We will also need a phototransistor, which is the device that will take in the light, which will determine what sound comes into the piezo, and at last also a variety of jumper wires. To start off this project, as we did in the other projects, we are going to start by connecting the 5 volts on the Arduino board and the ground to the breadboard by the jumper wires. Next up, we will connect the piezo to the Arduino board, to the breadboard, sorry. There we go. And it's very important, since it covers a lot of area, we can just kind of place it on top here so we can see which channel the piezo resides in. Now, one of the pins to the piezo needs to be connected to the ground, and the other needs to be connected to the Arduino pin number 8. There we go. Now that we've connected both of the wires to the piezo, we can just plug the piezo all the way in, so it's also all connected. There we go. Now we also need to connect the phototransistor. The long leg, as we did with the diodes and other things, the long leg needs to be connected to the power and the short leg needs to be connected to the ground. There we go. Let's just start by connecting to the Arduino breadboard here. And then we will take the short leg, and also, since we need the input from the phototransistor, we need to also connect it to the Arduino analog pin number 0. Then we just leave a spot here and connect the short leg of the phototransistor to the ground with a 10k milliohm resistor. There we go. And then we'll just connect the other side of the phototransistor, the long leg, to the power. There we go. Now that we've built a fairly easy circuit, we will go into the Arduino IDE and actually build the code to make this circuit work. After coming into the Arduino IDE, we need to set up a few variables for the project. One to hold the value of the phototransistor, aka sensor value. We also need one to determine the minimum value of the phototransistor, aka sensor low, and also one to determine the maximum value of the sensor, which we will call sensor high. We will use these two, low and high, to calibrate the sensor in the setup function. We also need to set up a variable for the LED pin number 13, which is a built-in LED into the Arduino board, which will help us determine when our sensor has calibrated. In the setup function, we will calibrate the sensor, aka phototransistor. We will do this to get a more fluid range of sounds from the piezo when we initiate the project. At first, we will determine the pin mode and digital write of the LED pin number 13. These will be respectively output and high. To actually calibrate the sensor, we will use a while loop. This works by taking in a statement and will run until the statement is not true anymore. In our case, since we want the sensor to calibrate for 5 seconds, we will therefore set our while statement equal to while millis is less than 5,000, aka 5 seconds in milliseconds. In the start of the while loop, we will start by acquiring a value from the phototransistor by using the analog read function. Next up, we will use two if functions to change the minimum and maximum sensor values, thus calibrating the sensor. In the end of the setup function, we will once again use the digital write function on the LED pin number 13. Instead of turning it on this time, we will turn it off to show that this time we are done with the calibration. In the loop function, we will once again acquire a value from the phototransistor by using the analog read function. To determine the pitch of the piezo, we will once again use the map function. As explained in the last project, the map function works by taking in 5 statements. The first statement is the incoming value, aka the sensor value. The next two are the minimum and maximum range of the incoming value, aka the sensor low and high, which we found in the calibration. And the last 2 statements are the minimum and maximum range of the outcoming value, which needs to be between 50 and 4000, since these are the values the piezo can put out. To actually make the piezo make sounds, we will use a new function called the tone function. This function takes in 3 arguments. The first is what pin the sound should play on, which was pin number 8. The second is what frequency the sound should be at, or what frequency it should be played at, which we determined by the pitch variable. And the third is how long the note should play. We will try 20 milliseconds at first, and then we can also always change it later on. At last, we will also input a small delay to let the sounds play properly. Alright, now that we've built the code, as you can see here, we need to do as we did in the other projects, upload the code using the USB 2.0 cable from the computer to the Arduino board. We do this as we do in the other projects, connect the Arduino board to the computer and press upload. There we go. Now we can see my Arduino board is connected up here in the top, and we are ready to press upload. Now, before I press upload, it's very important, as we talked about in the code, that in the setup function, we wrote a little something to calibrate the light sensor or the phototransistor. Now that when I press the upload function, the calibration will also begin. There's a little LED which you can see begin to light when I press the upload function when the upload is complete. I can just hold it up here. So if I try and press upload, there we go. Just takes a little time. There we go. It says done uploading. See here that the LED before it was turned on here, and now that we can see that depending on how much, just turn up here, depending on how much light I shine onto the phototransistor, I'll also put it up here, the pitch of the piezo starts to rise or decrease. See, so you can play do kind of different stuff on here. So that is kind of the project. You've built your first kind of speaker. If you enjoyed this project, make sure to watch my other videos. I will also be making more projects going more into depth with your creative mindset. So make sure to hit the like button and subscribe to the channel.